Hi guys, I know that some of you have been finding chapter 1 lesson 6 a bit challenging, which is our structure of the atom ions and isotopes. I've got the worksheet here. Hopefully this bit we remember that protons have a mass of 1, neutrons have a mass of 1, and electrons are almost 0, or 1/2000th if we're being picky in terms of wanting numbers. We also need to remember that protons are positive, but not just are they positive, they have a +1 charge. Neutrons are neutral, so they have 0 charge, and electrons are negative, they have -1. Okay, so we're told here about an atom can lose or gain electrons without the number of protons in the nucleus changing. So atoms will never end up in chemistry with the number of protons changing ever. It's only ever about electrons that we're dealing with. Okay. This means that they now become charged, and that means that they're now an ion. Anything that you look on the periodic table is an atom, and it is neutral, and it has the same number of protons and electrons. Once it's reacted, it may well not have that same behavior. Okay, so if we gain 1 electron, we've gained 1 extra negative thing, so we've gone from being neutral, so we've gone from 0. We've added a -1, so if we do the maths of 0 plus -1, that gives us -1, so we're at -1. If we're losing an electron, we start at 0, we're taking away 1, we're losing a -1, so 0 take away -1 gives us +1. So we end up with +1. If we do that for 2 electrons, then we end up being -2. If we lose them, 2 electrons, we end up with +2. Okay, that's what everything in group 7 will do. That's what everything in group 1 will do. That's what everything in group 6 will do. That's what everything in group 2 will do. Okay, so if we come over here, we need to refer to our periodic table, okay, which hopefully you've got a copy of. For fluorine, we have a mass number of 19 and an atomic number of 9. Magnesium, we're 24 and 12. And oxygen at 16 and 8. Whatever happens, the atomic number is the number of protons. That's always going to be the atomic number, so 9, 12, and 8. The number of neutrons is the mass number take away the atomic number. Whenever we want number of neutrons, that's what we do. So 19 take away 9 is 10, 24 take away 12 is 12, and 16 take away 8 is 8. Okay. Our number of electrons is where it becomes slightly more awkward, though. And we need to look carefully at the fact that fluorine has a -1, magnesium has a +2, or 2+, and oxygen has a 2- or -2 charge. Okay, so for this one, we've got 9 positives, so we have 9 from the protons. We're going to need to take away some number for the electrons, and that's going to equal -1. Well, if we're doing 9 take away something to get -1, it's got to be 10. So we're at 10. So 9 take away 10, and that's the charge from the protons, and that's from the electrons. Okay. Here we've got magnesium. It's got +12 because it's got 12 protons. We end up with +2. So if we do +2 take away 12, that gives us -10. So again, we're at 10 electrons. And then for our oxygen, we have +8, and that's going to be -2. So if we did the opposite of that, we've got -2 take away 8. It's 10 -10, so we've got 10 electrons here again. Okay, so that's our ions. And you need to be able to work out the number of electrons on any particular ion. Okay, but you need to look at the fact that our ions have these charges, and that means that they no longer have the same number of protons and electrons. Isotope then, something different. These are atoms of a particular element that have a different number of neutrons. So you'll notice here we've got hydrogen in hydrogen, deuterium, and tritium. That's what they're called. And they always have 1 proton because they're always hydrogen, but we have no neutrons, 1 neutron, 2 neutrons. Okay, so these are examples of different isotopes. So if we have a look at this sheet, that's what we're doing here. Okay, and the number of neutrons is always the mass number minus the atomic number. Okay, that's all we ever need to do if we're wanting to work out neutrons and we've been given a mass number and atomic number. So here, 35 take away 17 is 18. 37 take away 17 is 20. So I'll make that 18 a bit clearer. 79 take away 35 is 34. 81 take away 35 is 36. 12 take away 6 is 6. 13 take away 6 is 7. 16 take away 8 is 8. And 18 take away 8 is 10. So you can see that each of these, the chlorines have the same number atomic number, so the same number of protons, because that's what makes it chlorine, is that it has 17 protons, but they have different numbers of neutrons, and that's true for each of these. So I hope that's helped a little.